I'm Michael Hartinger. I'm a graduate student here at the Earth and Space Sciences Department at UCLA, and I am studying space plasma physics. And my specific research area is the Earth's magnetosphere, and specifically plasma waves. So very, very large scale plasma waves that are basically the same size as the Earth or larger. A plasma wave it can be either an electromagnetic wave or an electrostatic wave. An electrostatic wave is just something that only has a perturbation in the electric field. But basically a plasma wave is any one of those two waves that propagates in a plasma. So I work with satellite data, and one of the most important sources of data that I use comes from the Themis satellites. So Themis is a constellation of 5 satellites, and it gives us great information on how these waves look in space, how long they last, and how big they are, things like that. Having multiple measurements is great. It's something that we've only recently had in the last few decades, and particularly in the last decade or so with Themis and with another mission called Cluster. So Themis is based here at UCLA. The principal investigator is Vasilis Angelopoulos, and I'm his grad student. We've been working a lot on looking at these ultra-low frequency waves with Themis data. The near-Earth space environment is full of plasma. There's all different types of plasmas too. In general, the further away you get from the Earth, the less plasma there is, but there's pretty much plasma all over the near-Earth space environment. And there's also plasma coming from the sun, and we call that the solar wind. And so these waves, through a few different mechanisms, can make really high energy electrons. And these electrons are important to study because they can damage satellites, like communication satellites in geosynchronous orbit. And if you ever use GPS, for example, they can damage those satellites. So just think of, like, all of a sudden we lose 3 GPS satellites. We're basically, we're not going to be able to go in our cars and find our way to a museum or a baseball stadium or whatever we're trying to find our way to. So we want to understand the plasma waves, because then we can understand when they'll occur and when they'll affect the high energy electrons.